Section 1.5 is going to move us out of linear equations into another type of an equation. In particular, we're going to take a look in this section at quadratic equations. And we will start with what in the world is a quadratic equation. So a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. And the one condition is that the a value cannot be 0. Now we've seen some of these before. We saw them back in section P. I think P.5 when we were first looking at factoring. But in this section, we're actually going to have them set equal to 0. These are equations as opposed to just being expressions. So we're going to be able to solve them. We're going to be able to evaluate things in them, graph them, that sort of stuff. And in particular, we're going to start where we kind of started before with factoring. All right, so in some cases, of course, we've got factoring that's a little bit complicated, and in some cases, it's a little bit more straightforward. In this one, it's a pretty straightforward case. I've got an x and an x, and I need two numbers that multiply to give me -8. There just aren't a lot of options. 7 and 8. I'm sorry, 8 and 1. Or I've got 4 and 2. And so 4 and 2 are going to be the ones I'm going to try first. And if you'll take a look, I need, so 4 times 2, I need one of them to be negative, or I won't get a -8 at the end. So I can look at multiplying the inner terms, which would give me 4x, and the outer terms, which would give me 2x. And I need these two numbers to add, one of them being positive, one of them being negative, to a positive 2. That's the middle term right here. So in particular, I need a positive 4x and a negative 2x. So the x here, where the first term, where it says factor, where it says x blank 4, would actually have to be positive to give me a positive 4x. And then to give me a negative 2x, I need a negative on the 2. Okay, so I'm going to erase my sort of smiley face part of this. Okay, there we go. And what are we going to do next? Like if I stopped right here and I didn't have the equal 0, that looks exactly like what we've done before. So what does the equal 0 tell me I can do? Well, it tells me that I can set each of these terms individually equal to 0 so that I can solve the equation. X plus 4 equals 0, or x minus 2 equals 0. These are my two options. So subtract my 4 from both sides. So x equals -4. And on the second one, add a 2 to both sides. So x equals to 2. All right, so factoring is one way to solve a quadratic equation. We're going to look at a couple other ways to solve a quadratic equation. This next one's called square root. So if you take a look at the first one, it actually could be factored, but it doesn't factor very nicely. It's not very friendly. However, because there's only the squared term, that is, there's not a linear term, it is kind of nice to actually add the 8 to the other side. So I have x squared equals 8. And then if I've got only the squared term on the left and only a constant on the right, I can square root both sides. So as I square root, you'll notice, of course, that when you square root a value, or you take the square root, you have to put a plus or minus. So I have plus or minus the square root of 8. Now, if this were a square root that couldn't reduce, we would simply stop here. This one, of course, though, does reduce. It's 2 times 2 times 2. It's a square root, so I need 2 items underneath to remove it from the radical. I mean, I have 3 of them. So this x value equals plus or minus, right? And then it's 2, and then I still have one of these 2's underneath my radical. So 2 square root of 2. And that would be my solution for number 2a. Now on 2b, it isn't exactly the same. Now some of you might look at that and think, oh my goodness, I'm going to square this, I'm going to FOIL it out, I'm going to move my 20, and then I'm going to factor. And you can try that. There's nothing wrong with that being an option. But this happens to be in a very nice form to actually use the square root principle that we just used on the earlier problem. So in particular, you've got something on the left that's squared, and on the right you have something else that is a constant. So we can actually take the square root of both sides, just like this. I will have x minus 3 on the left. I'll have a plus or minus, because I took the square root on the right, of the square root of -20. Now, if you're dealing with, only real numbers, then of course at this point we would say that this is not a real number, and that's true. But we could also talk about this being complex or imaginary. So if you have a negative underneath the radical, just like we did back in section P7, we can take this and we can pull out the I here, leaving me with 20. Whether you do it in the same step or another step, you can also recognize that 20 factors into 4 times 5, and 4 is the same as 2 times 2, right? So I can pull a 2 to the front, or you could say the square root of 4 actually is 2. So I have x minus 3 equals, and this would be plus or minus the 2i, so don't forget the I, and then square root of 5. So the 5 is still underneath the radical because it didn't have a pair in which to pull them out. And then the last thing that you would do is you would add the 3 to the right, to the left side, which forces you to add 3 to the right-hand side. Now, don't go combining that with anything because it's not like any of the other items. The best you can do is to write the 3 in front, put your plus or minus, and then you've got your 2i square root of 5 for your final solution. And that's actually two solutions, right? That's 3 plus 2i square root of 5 and 3 minus 2i square root of 5. But we can consolidate it into a single entry by writing it this way. Another option for solving equations is the process called completing the square. Now we saw completing the square in our last chapter, or last section of this chapter, section 1. Actually 2 sections ago, it was section 1.3. And we used it to actually find the center and the radius for a circle. But we can also use completing the square to find the solution of a quadratic equation. So if we take a look at this one, we will do a couple of things. The first thing is we need to make sure that the coefficient in front of the squared term is a 1, and it already is here. If it weren't, we would divide by it. So let's say that there were like a 2 here to start with. We'd have to divide everything by 2. Even if it meant getting a fraction right here, we'd still have to divide everything by 2 to start, okay? Now we don't have that on this one. The second thing we need to do is we need to move the constant to the right-hand side. So in this case, we're going to subtract the 33 over to the right-hand side like this. And you'll notice I left a blank spot after my 12m. That was on purpose. I want to fill this in with the completing the square component. And the key we have in order to do that is to take the linear term, in this case negative 12, take negative 12, divide by 2, that would be negative 6, and then square it. Negative 6 squared, of course, is 36. And then we will add 36 to both sides. Now, the whole purpose in completing the square is because it turns it into the beautiful form of something squared. In particular, the first value is the coefficient, or the variable m. And then the middle part is actually the same sign as the middle term, so negative, just like the negative 12. And then you can say it's either the middle term divided by 2, that would be 6, or the square root of the 36, again also a 6. So you're going to get m minus 6 squared. On the right-hand side, we have negative 33 plus 36, which is 3. And we're done on that side. Now the beauty is that at this point, this looks just like part B on number 2, right? I've got everything on the left squared, and then I've got everything else that's constant on the right. And so we solve it the same way. We're going to take a square root. On the left-hand side, that gives me m minus 6. On the right-hand side, that gives me plus or minus the square root of 3, which doesn't simplify. And then we add the 6, and remember the 6 is not like the square root of 3, so you can't actually combine it, except to say that you would write them beside each other. So 6 plus or minus the square root of 3. And again, that's 6 plus the square root of 3 and 6 minus the square root of 3. Those are two different answers, but just written as one. All right, so I'm going to do an example now that doesn't have, there it is, that doesn't have the term linear. You know, it's not linear, or not linear, excuse me, not a coefficient of 1 on the x squared term. That's what I meant to say. Okay, so we do have a very nice fact that the constant is on the right already. So it's only the x terms on the left, only the constant on the right. But the very first thing to do is we need to have a coefficient of 1 on our x squared term. So we're going to have to divide every term, in this case, by 3. So unfortunately, there's going to be lots of fractions, but you know, it is what it is. So I've got an x squared now. I've got a 1/3 x, and I'm going to leave a blank spot, and this equals 2/3. So it's not especially pretty, but I do have the coefficient of 1 in front of the x squared. Okay, so the key is to take the middle term, which is 1/3, divide by 2 and square it. So 1/3 divided by 2, half of 1/3, would be 1/6. Okay, and then 1 over 6, quantity squared, is 1 over, and then 6 squared would be 36. So 1 over 36. If I add 1 over 36 to the left, I have to add 1 over 36 to the right as well. Now, this looks ugly because, we're dealing with fractions and so forth, but on the left-hand side, the factoring is still always very simple. It's x. I keep the sign of the middle term, which would be a positive, and then I either take the middle term divided by 2, if that's easiest, or I take the constant term, 1 over 36, and I square root it. Either way, I'm going to get a 1/6, and then don't forget the square on the outside of this. The next thing I need to do is to add 2/3 and 1/36 together. And in order to do that, I need a common denominator. So I'll multiply, oh, there's not enough space here. Let me try that again. Move this over a little bit. I will multiply the denominator over here by a 12 because I need to multiply by 12. It's still too large. Let me get a smaller font, pen size. That should do it. Okay. I will multiply this denominator by 12 because 3 times 12 is 36, and if I multiply the denominator by 12, I have to, of course, multiply the numerator by 12. So 2 times 12 would be 24, plus the 1, which would be 25, over the common denominator of 36. And believe it or not, that's not too bad because I can take the square root now, and to take the square root of the right-hand side means I take the square root of the top and the square root of the bottom. So the square root of the top is 5, and the square root of the bottom is 6, and we put a plus or a minus in front because we took the square root. And on the left-hand side, we have x plus 1/6 after we square root and square and cancel those. Okay, we're almost done. We're going to subtract the 1/6 to the right-hand side. Oops, 1/6, not just 6. And it's not especially pretty, but we can actually simplify both of these. So I have x equals, and I have 1/6 plus 5/6, and I have x equals 1/6 minus 5/6. Now, I had mentioned this process earlier, we just didn't have one that actually, was helpful to rewrite. 1/6 plus 5/6 would be 6 over 6, and 6 over 6, as you're very well aware, is 1. So one possibility is that x equals 1. On the second one, we have 1/6 minus 5/6. So 1 minus 5, which is negative 4 over 6, and that reduces, because they're both divisible by 2, to negative 2/3, and that's our second solution on this one. So negative 2/3 and 1/6. Actually, we missed a negative. I'm so glad I just saw that real quick. This was a negative 1/6. Let me go back and fix it. We've just got a couple sign errors. There's a negative here and a negative here. Okay, let's fix this. My apologies. Our answers are just going to shift a little bit. Okay, there we go. All right, no, negative 1/6, then 5/6 would be actually 4/6 on this one. 4/6 reduces to 2/3. And then on the other one, I've got a negative 1/6 and a negative 5/6, which gives me a negative 6 over 6, which will give me a negative 1. My apologies. Got the signs all switched up. Just those tiny little errors will just throw everything off, won't they? And of course, you could actually check these to make sure they work by plugging them back into the original equation if you were unsure or if you're just starting to double check. All right, we have one more way of solving that we're going to look at today for a quadratic equation, and that is called the quadratic formula. The quadratic formula is ax squared plus bx plus c equals 0. And if you take a look at this, I'm sure you've all seen this before, even if it has been a while. The quadratic formula says that I can actually solve this with a formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is one where at some point along the way I had heard that you can put this to the tune of Pop Goes the Weasel, and it goes something like this. X equals negative b plus or minus radical b squared minus 4ac all over 2a. So you'll probably never hear me sing in class again, so I hope that was fun. Now, you do need to recognize that in order to get the a, the b, the c to have the right, positive or negativeness to them, the right coefficient signs and so forth, you need to have everything on the left and equals 0 on the right. So if you take a look at this example right here on number 4, we don't have that right now, so I'm going to have to move everything to the left-hand side. So I'll subtract the 6x, and I'll add the 13 to both sides. So on the left I have x squared minus 6x plus 13, and then now on the right I have equals 0. So I can plug these into the quadratic formula then to solve. So x equals negative b. So negative b would be opposite of negative 6 like this, plus or minus the radical of b squared, so that's negative 6 quantity squared, minus 4 times a, which is 1, times c, which is 13. And this is all over 2a, and a is 1. So this gives me 6 on the outside, plus or minus the square root of 36 minus, and then 4 times 1 times 13 is actually 52, over 2 times 1, which is 2. All right, so that's 6 again, plus or minus. 36 minus 52 is negative 16, all over 2. And then the square root of negative 16, well, the square root of negative is going to give me an I. The square root of 16 is going to give me a 4. So this is 4i over 2, all over 2, right? And then we can actually reduce because every single term is even. So 6 divided by 2 is 3, 4 divided by 2 is 2, and 2 divided by 2 is 1. So my final answer from here is 3 plus or minus 2i. Again, that's two answers, 3 plus 2i and 3 minus 2i. If we didn't end up with a negative underneath there, of course that would mean that we didn't have an I come out of there. We could even end up with a 0 underneath the radical, and that would be possible, and then the plus or minus goes away because plus 0 and minus 0 are the same quantity. Now, this value that's underneath the radical, the b squared minus 4ac, actually has a unique name all on its own. It's called the discriminant. And the discriminant's value actually tells us whether our solutions are real or imaginary. So that means, like when you're looking at the part underneath the radical, if it's positive, certain things happen. If it's negative, certain things happen. And if it's 0, certain things happen. So that's what we're going to look at next. If it's positive, the part underneath the radical, the discriminant, then we end up with actually having 2 real solutions, because we're going to have plus that quantity and minus that quantity. If it equals 0, then the radical part actually goes away entirely, and when that happens, so does the plus or minus, which means we end up with 1 real solution. And if the quantity underneath the radical is negative, we're going to get an I involved, which means we have 0 real solutions. But 0 real solutions and an I involved means we're going to have 2 imaginary solutions, or complex solutions with imaginary parts. So simply looking at the discriminant can tell us what kind of a solution we're going to get, and that's actually going to be our last example for today. Number 5, how many and of what type solutions will the following have? So you can find the entire, solution if you would like for this one, but there's no need. All you really have to test or to check for is the b squared minus 4ac, and then find out whether or not it's positive, negative, or 0. So this is actually already set equal to 0, so that's very friendly. The b value is negative 7, so this is negative 7 squared minus 4. Oops, I messed up. This is saying ac. My apologies. 4 times a, which is 3, times c, which also happens to be 3. So negative 7 squared would be a positive 49 minus 4 times 3, which is the same as 4 times 9, is 36. 49 minus 36, which happens to be 13, is clearly a positive number. And if you get a positive number, according to this chart we created over here, you're in case sort of number 1 up here, right? And case number 1 says that we have 2 real solutions. So there are 2 solutions. That was part of what we were asked for, right? That's the how many. And then the what type is that they're real. So there are 2. We could actually write it all together if we want. 2 real solutions. The solutions are real numbers.